The question I left you with last night for homework was the one that's on the board here right now. We have a 150 kilogram object with a coefficient of static friction, a coefficient of kinetic friction. We want to find the force of friction, static or kinetic, in 4 different situations. When we apply a force of 700, 1500, 5,000, or 8,952,679,289.3256. The first thing we got to do is figure out whether it moves in these scenarios or not. Does it move when we apply a force of 700? Does it move when we apply a force of 1500? Does it move when we apply a force of 5,000? Does it move when we apply a force of 8 billion? How do we find out if it moves or not? How do we find out if it moves? How do we find out what type of friction we have, static or kinetic? You guys remember the deal with static friction? Okay, that's the trickier one, right? Static friction, I sometimes call stubborn friction. Why do I call it stubborn friction? Because it pushes on the object as hard as I push on the object. If I push with 5 newtons, it pushes with 5 newtons. If I push with 10 newtons, it pushes with 10 newtons. If I push with 20 newtons, it pushes in the opposite direction with 20 newtons. It's like it's taunting me. It's taunting me. Like the harder I push, the harder it pushes, until it reaches a maximum possible force. At some point, there is a maximum, at some point, I push harder than the maximum possible force of static friction, and then I win. Static friction gives up, and the object moves, and it becomes kinetic friction. So in order to determine if it moves or not, I got to see if I'm pushing harder than the max force of static friction. What is the max force of static friction in this question? How'd you find that out, Blake? Okay, so we found FSF max is equal to the coefficient of static friction times the normal force. The coefficient of static friction is 0.80, and the normal force for us right now is always just m times g, mass times 9.81. You saw a few scenarios where it wasn't equal to m times g, but we're not dealing with that with friction quite yet. Okay, so for now, it's always just m times g, 150 times 9.81. And Blake, what did that equal when you multiplied those numbers together? 1,177.2 newtons. Okay, thank you. There's the max force of static friction. Now, that's not the answer to any of these questions. Remember that when we solve for this, we're not solving for the force of friction. That's not what friction is. That's what friction could be. That's as big as friction, static friction can be. All right, when I apply a force of 700 newtons, do I move it? No, because I'm not exceeding that maximum possible force of static friction. So we're going to say that this is static friction, not FSF max, just FSF, the force of static friction. What's its value? 700 newtons. Okay, it's however hard I push, unless I exceed the maximum possible value, right? Just however hard I push. What about 1500? Does it move then? Yes, it does. All right, so it's not static friction anymore, right? Now it's kinetic friction. Let's find the value of kinetic friction. We're going to do it almost the same, except we'll use a different coefficient. Kinetic friction has a value of 0.75. Normal force is 150 times 9.81. We would expect this value to be smaller, not necessarily smaller than static friction, but smaller than the max static friction, right? What do we get for this? Blake, do you have that one? 1,103.625. Thank you. Now, that's not a lot smaller than static friction, right? Because the coefficient is almost as big, right? You're going to find that it's sometimes a bit smaller, sometimes it's a lot smaller, and this time it's a bit smaller. Okay, in B, does it move? Yes. So what is the value of kinetic friction in B then? What's the value of kinetic friction in B? It is kinetic friction, right? Because it's moving. What's its value? John? Good. We got to put that in scientific notation because we got to be in 2 digits, 1.1 times 10 to the 3 newtons. Does that make sense? We used, to calculate that force of kinetic friction, we had 3 digits, We had 2 digits. We had 2 digits. Final answer should be 2 digits. 1.1 times 10 to the 3 newtons. What's the force of kinetic friction in C? 1.1 times 10 to the 3 newtons. Once I push harder than 1177, then kinetic friction will always be the same value, 1.1 times 10 to the 3. That includes question D. Even when I push with this massive force of 8 billion newtons, the force of kinetic friction is still 1.1 times 10 to the 3 newtons. Is that good? Here's another example. This says a 30 Newton force is required to cause a 10 kilogram object to begin to move. Calculate the coefficient of blank friction between the object and the floor. What are they giving me here in this question? 30 Newtons force is required to get an object moving. Like, I'll give you a hint. It's not the applied force per se. I mean, they are giving me directly the applied force, but that's also equivalent to something else. What is it? Yes, that's FSF max. The force required to get an object moving is the same as FSF max. So we want to calculate the coefficient of, what type of friction would it be that we're going to get from this question? Static friction, right? So it is going to start moving now, but we don't have any information about kinetic friction here, so there's no way we can find it. All right, I'm going to say FSF max is equal to mu s times the normal force. And assuming this is on a horizontal surface, the normal force is just m times g. We're looking for mu. Let's take the Fn over by dividing. FSF max is 30 newtons. The force is required to get it moving, and Fn is going to be 10 times 9.81. We'll do this on the calculator together. Let's say 30 divided by, use some brackets on the bottom, 10 times 9.81. Well, I always get this question about the 9.81. Shouldn't it be negative? Now, when we're dealing with friction and normal force, we're dealing with the magnitude, right? So gravity is negative, but we're only looking for the magnitude here. So make it positive. 30 divided by 10 times 9.81 gives me a value of 0.3058. How many digits should we round that to? 2 digits, right? This is 2 digits. This is 3 digits. Final answer should be 2 digits, which is going to be what? 0.3058. We want to round it to 2 digits. That's a 5, so it means it rounds up. So we're going to make it 0.31. Good? Is that good? Now, we're not asked to find the coefficient of kinetic friction here. We can't. With the data that we're given here, we can't. But if we did, what would we expect a reasonable value for kinetic friction coefficient to be? Give me a value that it could be. Could it be 0.45? No. Could it be 0.25? Yes. Less than 0.31, right? Could it be 0.30? Yep. Could it be 0.32? No. Okay, one more little example, then we'll let you work on a couple worksheet questions. This one says a force of 40 newtons is required to keep an object moving at a constant velocity. Look at those words, constant velocity. If it's moving at a constant velocity, it's in a state of equilibrium. That means the forces must balance. Cancel, balance, yeah. Forces must balance. Okay, if there is a force that's required to keep it moving at a constant velocity of 40 newtons, then what must the force of friction be to balance that 40 newtons that I'm pulling with? Marcos? 40 newtons. What kind of friction is it, static or kinetic? Yeah, this is going to be the force of kinetic friction, right? Does that make sense, guys? Like, we're strictly speaking, we're given the applied force, how hard we're pulling. But since it's moving at a constant velocity, that force is going to balance kinetic friction because it's in a state of equilibrium. So we are going to find the coefficient of kinetic friction this time. And we're going to do that by saying FKF is equal to mu k times the normal force. Now it's pretty much the same as the last question, right? Now this is not FKF max, this is just FKF, which is 40 newtons divided by the normal force, which is 10 times 9.81. Okay, let's say 10, no, sorry, it should be 40. 40 divided by 10 times 9.81. Okay, use your brackets on the bottom. You get 0.4077. No units. How many digits should that be rounded to? The 40 newtons is 3 digits. 10.0 is 3 digits. Final answer should be 3 digits, right? So this is 1, 2, 3. Our fourth digit is a 7, which means the third digit is going to round up. Good. So we're going to make it 0.408. That's the coefficient of kinetic friction. Give me an example of a number that static friction coefficient could be. I mean, there's an infinite number of them, right? But what's one value that static friction could be if my coefficient of kinetic is 0.408? 0.6? Yeah. Static friction coefficient could be 0.6. Absolutely. Could static friction coefficient be 0.9? Yep. Could static friction coefficient be 0.3? No, because it's going to be bigger than 0.408. Good. All right, I'm going to have you take a look now then at worksheet number 13, the remainder of worksheet number 13. I'd already assigned question 2 and 3. I want to take a look at the rest of those questions. I think there's 5 or 6 questions on the page. Spend a few minutes now working on the rest of them.